Hi everyone. So let's see today's question. So the question name is maximum multiplication score. So let's go to the question description now. So you are given an integer array A of size 4. The array A size will always be 4 and another integer array B of size at least 4. That means the array B will have at least 4 and it can have more than 4 like 5, 6, 7, 8, like whatever the number be. So then it is given you need to choose 4 indices I0, I1, I2, I3. So from this B array you need to choose any 4 indices and then from the array B such that I0 is less than I1, I1 is less than I2, and I2 is less than I3. So the indices which you will choose like 0, 1, 2, 3, so they should be in an increasing order only. Okay, your score will be equal to the value A0 into B of I0 plus A1 into B of I1 plus A2 into B of I2 plus A3 into B of I3. So basically, whatever four elements you will choose from this B array, they will be multiplied with the array elements from the array A. Okay, so suppose if you choose this first element from B, so this 2 will be multiplied with this 3, and then suppose if you choose this 4 as the second element, then this 4 will be multiplied with this 2, and then suppose if you choose this 2 from this, then this 2 will be multiplied with this 5, and then if you choose this minus 7, then this minus 7 will be multiplied with this 6. Okay, so that's how they will be multiplied. So once you have this, so you can choose any four indexes from B, but just make sure like they are in an increasing order and return the maximum score you can achieve. Okay, so we need to tell what's the maximum score we can achieve by selecting four indices from this BR. Okay, so if we go to the first test case, so the first test case, the result which we are getting from is with indices 0, indices 1, 2, and 5. Okay, so when we have chosen index 0, so this 0 is being multiplied with this 3. Then we have chosen the first one, like the minus 6 one. This 6 minus 6 will is getting multiplied with 2. Then we have chosen this 4. This 4 is getting multiplied with 5. Then we have chosen this 2, and this 2 is getting multiplied with this 6. Okay, so that's how they're getting multiplied, and we are getting the answer as 26. So now, how to do this question? So if you go through the constraints, so before even getting to the approach, if we see the constraints, so the length of B is 10 to the power 5. So like the ideal solution would be till O of n log n at max. We can go till O of n log n of or O of n. Like I think like these kind of solution can work. Okay, so now if we think about it, there is not a particular way in which I can decide like with which element this first element of this array A should be multiplied with this from this. So there is no way I can identify like whether it should be multiplied with this 2 or whether it should be multiplied with this minus 6 or which of these. Okay, so if we are not sure like how to decide like which of them, then we can decide by checking out by getting it multiplied with all of them. Like we can try all the possibilities and then we can see like which of them which will give us the maximum score. So what do I mean by that? This is for this 0, I can try to pair it up with this 2. I can try to pair it with this minus 3, 6. I can try to pair it with this 4. So that's how I can try all the possibilities. So trying out all the possibilities also, but at the same time, okay. So this will be my DP approach. Why? I'll tell you. So in this DP approach, I'll just check each of this elements value corresponding to each of this B's value, and then after I have like tried out all the values, I'll be getting a result. I will be memorizing it, and then if it is required further, I will be returning it. So because we are not sure like which elements to choose, we are trying out all the possibilities. And if we even like go ahead and like do the DP for it, the DP will be of O of n into 4. Why? Because first choice will be us having like which index we are at. Okay, or Okay, so which index at in this B we are at. So this can have n choices. Okay, so this n choices will be multiplied with this four choices. So which of these values this needs to be multiplied with? So the time complexity will be O of n into 4. So n into 4 is also like O of n only. So this can get accepted. Okay, so let's see the code for it now so that things are more clear for it. So see, what I have done over here is, first of all, I have taken a mem array. So this is just the DP array. So in this DP array, I'm just initializing it with the length of this array A and length of this B. So I can also put 4 over here, as this is always 4, but never mind. So this will be A dot length into B dot length. Okay. Then what I'm doing is I am just calling this generate result function. This generate result function is having four parameters: this current position, index, A array, and B array. Okay. So what this current position means? This current position means, like in this array A, we have A0, A1, A2, A3, and yeah, so till A3 we have, because we have 4. So this current position will be in telling me like which A's position I am checking for, like which A's position is being decided for, like this A0 needs to be multiplied with which BI value. Okay, so B0 ke saath, like we need to multiply with B0, or we need to multiply with B1 or B2. Okay, so this current position is the index for this A, you can think, and this index is the index of this B. Okay, so what I'm doing is, so in the recursive case, I'm checking if the current position is 4. So suppose while traversing, I have like mapped all of these. So I have mapped like this 0, this 1, this 2, and this 3 of array A with all of the B's array element. Okay, so once I have mapped, like I cannot generate any more result as such. So I'll be returning a 0 from here. Okay, and then if suppose this A's element were not like fully filled. Okay, so this 0, 1, 2. Suppose I was at 2. Okay, and I have exhausted my B. So I have I was at n minus 1, and now I am at n. Okay, so all the elements of B I have exhausted. So I don't have any more choice. So this is a invalid case. So for this invalid case, I am just returning a negative value. Okay, so generally in the case of recursion, when we have to like get the maximum, we put minimum in the invalid case. Okay, so that's why I'm putting this negative value, a very high negative value as written, because this is a invalid case, because my current positions of array A are not decided fully, and my B is exhausted, like I have exhausted my B search. Okay, then I'm just checking if I have like if I'm having the answer for this current position and index already stored, then I will be just returning it, or else. Now see, this is just a simple take it or not take it. Okay, so at every position I will be having two choice. So like this B index, should I consider it for this A current position or not? If I consider it, what I'll do, this A current position will be multiplied with this B index. Okay, this will be multiplied, and then I will call this generate the result for the rest of the array. Okay, so then suppose if I was deciding like this A0 needs to multiply it with B, which B value. Okay, so suppose if I have decided for this A of 0, then I will be incrementing the value of current position. So I'm incrementing the current position by +1. Also, since I have decided for this B, since I have decided like I will consider it, so I'm just doing a index +1 over here, and this A and B are getting passed as it is. Okay, now second choice is I will not take it. So I will not take it. So second choice is just saying for this A of 0, suppose if I was at B2 and I was deciding like whether this B2 should be multiplied with A of 0 or not. And suppose if I decide I will not take it. Okay. So what I will do, I'll just say like this current position will remain as it is, because I still need to figure out like which value needs to be multiplied with this A of 0. Then I will just increment this index +1. Like I have decided for this 2, like this 2 of B. will not be multiplied with a of 0. So try out with the other possibilities is starting from b of 3. Okay, so index plus 1. Basically, try out with index plus 1. And once I have the result for this both, I'll just taking a maximum of take it or not take it, and then I'll be returning them in the result. Okay. So yeah, and I am storing that in the DP array, or in my case, I have, let's just name it mem array. So memoization array. So this memoization array will be filled. So yeah, that's pretty much about it. There is just one more caveat to it. Why I have done this multiplication with one. Okay, so I have multiplied it with into 1L because in the constraints it's given to us like this b of I can be till 10 to the power 5. Okay, so now suppose if there are uh, two values. Okay, this okay, so as you can see, this a of I and b of I both can be till 10 to the power 5. So when I'm multiplying two 10 to the power 5 values, they can easily surpass an int. Okay, so int is around 10 to the power 9 it can hold, but 10 to the power 10 it won't be able to hold. So that's why what I'm doing is I'm explicitly making one of the value as long so that this values also get converted into long. So indeed this whole is a long. Otherwise, if suppose both of them would have been int, so int into int would have been given me a int value only. But since I am multiplying it with a int value with a long value, so behind the scenes Java will convert this into a long value. So that's why I am doing this into 1L. So yeah, that's about it. This was just a simple like DP DP question, and we have solved it with recursive approach, and we have memorized the solution. So yeah, the time complexity I have already told, it's O of 4n, and the space complexity is also order of n only. Okay, so yeah, that's about it. I hope I was able to make you understand the approach. If you have any doubts, you can ping me in the comments. So yeah, that's it. Thanks.